Good afternoon, everybody, and welcome to this great webinar on solar panel recycling and EPR, brought to you by NERC and NEMOA. I'm the Executive Director of NERC, and with me is Terry Goldberg, who's the Executive Director of NEMOA. Before we get started, I'd like to review some housekeeping details. This webinar is being recorded, and the recording will be available by tomorrow, as will the PowerPoint presentations. You'll get an email in 24 hours from GoToWebinar giving you the link to get to that. So yes, recorded, yes, you'll have access to it. Those are the most popular questions we get. Now, since we're talking about questions, we're going to, oh, here comes Al. We're going to, I'm going to do all the bios up front. But we're going to ask, and then we're going to hold the questions until the very end. So we'll hear from all the presenters. So how do you ask questions? If you're not familiar with the GoToWebinar platform, or if you haven't used it in quite a while, look on the right-hand side of your screen. And either there'll be a dashboard opened or a little orange arrow. If the dashboard isn't open, click on the orange arrow, and you'll see down the screen, there's a gray band with an arrow that says questions. You open that and you type in your question, and Terry is going to be handling the moderating for the question and answer period. So you can put in your questions, as soon as we put them in now, but as soon as we get started, and they'll be asked as we can at the end. So I'm really looking forward to this. We have three terrific presenters this afternoon. Going first will be Dr. Ricky Sinha, who is a senior scientist of sustainability research at First Solar, where he leads the company's research on product stewardship, including end-of-life management. He is currently serving on the R2 Technical Advisory Committee, developing a recycling standard for solar panels, and is also a member of the International Energy PVPS Task 12 Committee on PV Sustainability. Following him will be Kelly Kehoe, a co-founder of Green Eye Partners. She has been working in the recycling and waste industries since 1992. During those years, she has worked as an environmental, sustainability, health, and safety auditor and conducted on-site audits of metal smelters, CRT furnaces, battery recyclers, and mercury retort sites worldwide. Since 1999, her work has been exclusively in the electronics recycling industry, supporting companies in certification of ISO, R2, RIOS, and E-Stewards. Kelly serves on the Technical Advisory Committee, along with Ricky Sinha, for the R2 standard and also for the RIOS standard. She currently serves on the RIOS board and served with EPEAT as both the standards assessor and verification auditor. So be wowed. I am. Okay, so the final speaker is going to be Al Salvi, who's with Washington State. He's the Technical Services Unit Supervisor for the Solid Waste Management Program. He's actually with the Department of Ecology. He has spent 20 years with the Washington Department of Ecology. Waste Management Program. In this role, he supervises up to 10 staff, including the program's IT team, oversees Washington's electric, mercury lights, paint, and PV model product stewardship program. So it's going to be a great webinar. Thank you to everybody. Ricky, I'm going to make you the presenter, and everybody else is allowed to turn their cameras off themselves. Great. We can see it perfectly. And if you could put it back in slideshow, that would be perfection. There you go. And thank you. We look forward.
Great. Lynn, can you hear me okay?
Yes, I'm nodding.
Okay, great.
Thank you.
All right. As Lynn said, I work for First Solar, and I was asked by Lynn to give a snapshot of the recycling process and markets. So kind of give you a sense that solar panel recycling can actually work commercially, and then you'll get a flavor for the policy side and the standards side after I speak. So just a few words on First Solar. It is a major solar panel manufacturer. It's the largest manufacturer in the United States and in the Western Hemisphere. and it produces what's called a thin film photovoltaic technology, which is a different technology than the silicon-based that is also very commonly deployed. It's been around. First Solar has been around for over 20 years, and it was founded with a mission of making solar affordable and mainstream. And so this, back in 1999, solar was a pretty niche technology that was quite expensive and therefore not mainstream. And First Solar's, through its thin film manufacturing process, was able to lower the cost of solar. Initially, the first company to break the $1 per watt barrier, and also deploy at scale. So the first company to really start doing large-scale ground mount utility-scale solar. And all those things contributed to where we are today, where solar is a mainstream pillar of the energy transition. An important fact on this slide is on the very left. The early milestone that's relevant to today's webinar is that First Solar created the first global recycling program in the industry back in the 2005-2006 timeframe. So we've been recycling for a long time, over 15 years, and that's what I'll be talking about today. Now, I have not always worked in the solar industry. Before joining First Solar, I was in, I was an environmental engineer. I was an atmospheric scientist. The reason I got really excited about solar was this type of graph where it's just such an abundant resource. It dwarfs other renewables, it dwarfs fossil fuels, and it's there year after year, and it's there all around the world. So that's the reason why solar energy is where it is today and where it'll continue to be as a key resource for the planet for energy. And all that being said, there's a lot of hardware to harvest that solar energy. And on the top left, you see a schematic of how the complexity of our material use has evolved over time as the world is industrialized, and as we deploy the solar and wind and other renewables, we're going to have to harvest more and more of the periodic table. And there is a clear agreement that solar energy will continue to grow, and as we need to decarbonize our societies, and that'll also generate waste over time. On the lower right, you see waste projections starting in the 2030 to 2050 timeframe, really growing, and so we're going to have to integrate, not just improve the technology, but start to integrate circular economy thinking into this industry to make it sustainable. So all that hardware that's being put out to harvest the sun and wind needs to be recovered. And not only that, we need to start using recycled content in our new products to fully make it circular. Before I get into the recycling process and markets, I wanted to give you a feel for how recycling has evolved in the last 15 years or so. So initially, it was a voluntary activity. As I mentioned, First Solar started their global recycling program. There was another collective effort from PV Cycle to get companies to voluntarily commit to recycling. That voluntary effort transitioned into a mandatory law in Europe. The EUE directive in 2012 took solar into its scope, and so since then, since that time, the last 10 years or so, solar panels in Europe have to be recycled. They can't be landfilled. And the next step in the evolution was to standardize or to create standards specific to solar. The WE directive is kind of general in that it requires a certain level of collection, a certain level of recycling by mass, but it doesn't capture the specifics of solar panel recycling. And so there was some effort to standardize, to create treatment standards specific to solar. And then more recently, there's been efforts to create leadership standards where the very best actors who are doing, the highest yield recycling are getting recognized. And the work that we'll talk about later with R2 it will need to be added to this timeline. And also the work from Washington State on creating mandates in the U.S. Will need to be added as well as that program rolls out. So how does the recycling work? The diagram on the right kind of shows the general steps of recycling. First, you have to collect the material, then you have to dismantle it, and then you have to try to recover as much as you can from it. Whoops, sorry about that. And then find off-takers for what you've recovered. On the left-hand side in the circles, I've shown what are some of the key challenges to doing all this. If you think of a solar panel, a good analogy would be to think of it like a sandwich, where there's typically a glass on top and either a glass on bottom or a backsheet polymer on bottom. So that's the bread of the sandwich, and inside the sandwich are the solar cells, and these are the semiconductors that are harvesting the sunlight. And there's also some metallization in there, the electrodes that are collecting the current, and then allowing that panel to be connected to other panels or to the grid or to an inverter to be able to deliver that electricity to the end use. If it's a sandwich, in order to recycle that sandwich, you need to be able to open up the sandwich. So take the top glass and the bottom glass or bottom polymer out and open up the cells. Now, in order to do that, you have to delaminate or what's called remove the encapsulant that's holding that sandwich together. And so that's the kind of one of the key challenges is. Now, these solar panels were designed to be very long-lived in outdoor environments. So they're very tightly sealed. They're a monolithic material. So it's actually pretty hard to open up that sandwich. And so that's why that's one of the challenges. Another one is getting the panels in the first place. So now there's two main types of systems out there. There's large-scale centralized systems where all the panels are in one spot. It's relatively easy to collect because they're all in one place. Then there's the distributed systems like on rooftops where they're smaller projects. They're scattered. Now, oftentimes they are there's an installer network that put those panels out on those roofs, and so they can be the aggregator that helps collect them when they reach end of life. But they are a little harder to collect when they're smaller and more distributed. And then the transport costs as well are a big part of the recycling challenges to affordably collect and send these panels to the recycling facility. The third issue that I will get into a little more is called high value recycling. So if you're talking about the sandwich, if you're only recycling the bread, it's not really recycling. So that's often what happens is the easiest thing to do is to take the glass and the backsheet and then discard the solar cells inside. So you're basically not recovering the inside of the sandwich, which is the most critical part for photovoltaic light conversion. And so we need to make sure that there are specific treatment standards that say, okay, it's great you've recovered the heavy stuff, the glass and the aluminum, but you need to recover those solar cells as well, because that's where all the working metals are that are turning light into electricity, and those are the metals that are kind of not as abundant as glass maybe. So this is the basic repeat of what I just said, that high value recycling is what's needed to make this a sustainable circular process. And it's easy to just take, to meet the law. For example, if there's a requirement, you have to recover 85% by mass. You can do that if you just take the glass and the aluminum frame, but then you're missing the whole solar cell, and that's where all the environmentally sensitive, the valuable and energy-intensive materials are. So if we can do all that, if we can get to high-value recycling, there's a very large revenue stream, billions that were 15 billion by 2050 that was projected by the International Energy Agency. If we can get to high-value recycling. So what's an example of what high-value recycling looks like? So this is the First Solar's approach to recycling and product stewardship. It's a life cycle approach, and we do have the benefit that we are both a manufacturer and a recycler. So what that means is we can get involved not only at the end of the life, but at the beginning of life, at the design phase. And our recycling team actually has input into any changes to our product, and will intervene if the change means that it's disrupting our recycling process, or some new tool needs to be added to make it recyclable. And we also source our raw materials from the mining waste in the zinc and mining and copper mining sectors. So we're taking I mentioned earlier that the circularity is not just about recycling the end of life waste, but it's about using recycled content in your new products. And so we're taking waste from the mining sector and using it in our new panel production. And we'd like to also do that with our other components, whether it's glass or aluminum or other components, and make sure we're using as much recycled content as we can. And then I'll get into the recycling process, which is, as I mentioned, been around for over 15 years. And this is just a picture of our Ohio recycling facility, where this is a version 3 facility that, back in 2005, it was version 1, and we've been doing continuous improvement. And this one is a continuous process. So the glass gets crushed in a shredder and then goes into this chemical processing tank, which loops around the material and recovers over 90% of the semiconductor and the glass as products. We have these facilities around the world in the U.S., in Ohio, in Germany, in Malaysia, and Vietnam. We're also building one in India. We're building an additional one in the U.S. So we have regional hubs for getting these materials and recycling them. And basically, the process is a 2-step process. As I mentioned, there's a crushing step where the solar panels get shredded and hammer milled to get to small sizes of millimeter sizes. The reason for that is that it weakens that encapsulant that's holding that sandwich together. It allows us to open up the sandwich once that crushing is done. And then there's a chemical step of leaching the semiconductor metals out of that sandwich using a combination of sulfuric acid and hydrogen peroxide. So it's a oxidizing and acidic solution. We create clean glass and reusable semiconductor metals, as well as recovering the polymers, and they can be, the semiconductor can be used in our own solar panel manufacturing. The glass gets used in other glass products like container glass, and then the polymers can be used in rubber products where there's an off-taker. So overall, we have this, we're definitely encouraging the circular economy as a way of sustainably growing the solar industry, so that all that hardware that we're putting out will have a home and not pose a waste problem, and also that we'll have the materials we need to continue to scale our industry. And I think First Solar has shown that all this can be done in a commercial scale. It's not just wishful thinking, and I I look forward to hearing from the other speakers about how the policy side and the standards side will be helping all this. Thank you.
Good morning, or I guess it's afternoon for a lot of you, isn't it? As Lynn said, my name's Kelly Keogh, and I've been working in the recycling industry, standards industry for a long time. And what's new for us, of course, is the idea of preparing for standards for solar panels in our industry. We've been working on the standards for electronics recycling, and then some of my work with EPEAT has also been involved with all different types of electronics, from screens to photocopiers to phones, looking at solar panels now. So a lot of my career has been involved in creating standards and being part of the consensus group that creates those, and trying to find places between the manufacturing world, the recycling world, where we can all come together and create a standard that makes sense and that's affordable, right, for everybody to be able to participate in. So my presentation to you today is a lot about the first standard that's implementing the addition of solar panels to its process. How we work with standards, the value they add, what we're currently seeing. So for right now, when we talk about standards in any industry, but in particular the recycling industry, we're really looking at creating the best management practices for the standards. As Ricky noted, the WE directive they're much farther along in this there. We tend to, in North America, not create standards for recycling or reuse. We tend to not to have regulations or directives, so the WE directive is actually a regulation. You are required to recycle there, and then not only are you required to recycle those units, you also have to meet the requirements of the WE directive for managing electronics equipment correctly. So they set that standard. It's different there. They have much more control over things. We have a more free marketplace in North America. We tend to not like regulations, and that's why standards have been important for North America, but also it turns out the world. And so there are two recycling standards. The one we're going to talk about today in the electronics industry is the R2 standard. And like I said, sometimes it's difficult to create regulations in the US or to get them completed. I would give an example of the CRT regulation for CRT tubes, which by the time it was created, it took 8 years to complete. And then when it was created, it was immediately outdated. So, and we saw a lot of problems with recycling CRTs in our industry. I'm hoping that we will not have those problems in recycling photovoltaic cells. So we want to use the standards to create a best management practice and standards that are created by a broad range of constituents, so manufacturers, consultants, regulators, recyclers themselves, environmental organizations, so that everybody has input. We want the standard to be manageable and practical. And we also want there to be a way to verify that the standard is actually effectively changing the industry. So in terms of value, what we saw in the electronics recycling industry when we first started with the standards was a fairly simple type of industry that didn't have a lot of environmental health and safety rules to go by, other than a few that were governmental, but a lot of those industries were fairly informal, and it was difficult for them to get their arms around requirements, what that looked like and how they moved forward. So in terms of value for environmental health and safety, in particular worker health and safety, it was a huge change in the electronics recycling standard to begin the certification process with a lot of these recyclers. The R2v3 standard, or the R2 standard, last count, I think we were about at 1,000 recyclers worldwide. Many of them are in North America. And I would say it would be a barrier to starting a business at this point if you were not certified. So in order to be a part of a couple different purchasing chains or to receive material from different companies, manufacturers, you need to be able to verify that you're R2 certified. So this kind of had a closed loop effect in making more people want to get certified and keeping their certifications valid. The R2 standard needs to be rewritten every 5 years. It took 5 years to do the latest version, and I am no longer on the TAC. I was on a TAC or the Committee of Excellence for about 16 years, and now Ricky, I think, is on the TAC, and he's aware of what that process is. I am on the photovoltaic cell group just because I have all this historical information of how we work together to build consensus for the most part. When we talk about value from environmental health and safety, we also talk about just best management practices and organizational management of procedures, document control, just things as simple as a monthly facility inspection and training employees and getting their feedback in health and safety. Those are the kinds of things that may not occur if you don't have a standard to sort of guide you. Because remember, with standards, you are also audited annually, and there's a continual improvement loop. So if I'm doing something poorly or not keeping to the standard during that audit process, that's going to get called out. I'm going to have a corrective action process and then show that what I'm doing to make sure that doesn't occur again. So there's a continual improvement. There's a constant checking on how you're doing. It's all a third-party process. So the standard itself is accredited through an industry that actually manages how people are trained and licensed to do the auditing. So there's a lot of built-in third-party work that make sure that everybody's adhering to the requirements of the standard. Currently in the industry, in the electronics recycling industry, we've been seeing photovoltaic modules hit the floors of our recyclers for about the last 15 years. Everyone's been talking about it for, I'd say, 10 years, and there were some of us that wanted it added to the standard in our last revision, but not everybody was ready. So everyone's ready now, and that's what we've all been working on together. So we see them in our facilities because that's the type of material we tend to recycle. It's similar to the things we have been recycling. It's similar to flat screen TVs and the circuit boards and the laminated glass. It's similar to CRT glass in the sense that you're moving with the glass product. There's a metals recovery component to all of the different modules, as Ricky stated, and a lot of that material will be managed by the same types of facilities for end of life for circuit board recovery with precious metals or other metals recovery. So we see it in our industry now, and then of course there are some dedicated recycling facilities like Ricky noted that are solar industry facilities, closing the loop and increasing their sustainability. When we talk about risks really in our industry, we're always looking at environmental health and safety, worker protection, protection of the environment itself, spillage, air pollution control for shredding systems. So we're trying to consider how all of the recycling process affects both worker health and safety and the environment. So why did we consider using the R2 standard for photovoltaics? So R2 already has a really robust recycling process within itself, and it also, like I said, is used to dealing with a lot of the constituents that are in photovoltaic panels. So that's why it was sort of considered part of it. But as I said before, we were already seeing it at some of the recyclers' facilities. So it made sense to keep an industry that already did, you know, metals recovery, glass recovery, processing, shredding, sorting. It sort of just blends well into some of the processes that Ricky just showed. It was also the photovoltaic and R2 stakeholder group recommendation. So like I said, we had talked about it in the last writing of the standard, which was, I might be 6 or 7 years now, I said 5, but it was a discussion about whether or not to include it at that time, but people weren't quite ready for it. So it made sense to get it added at this point. And like I said, the processors are already receiving them or they're asking about them. And now the last year and a half, I'd say there are processors across the US at least that are starting to gear up and purchase equipment and consider what it's going to take for them to start collecting material. And I mean, like Ricky said, you saw the volume of material expected to come in and the age of material that's starting to hit the recycling floors, depending on when those units were deployed. And again, regulations really will take too long. And the WE directive is way ahead of us and already has the system set up. But even getting something like that set up in the US, we're 10 to 15 years away. So the R2 standard is built on a core of requirements for recyclers that include having an environmental health and safety management system to manage the things we talked about, a hierarchy of recycling for always having reuse prior to recycling and metals recovery, and the last option being landfilling or waste to energy choices. We also have a strong test and repair section in the R2 standard that's already part of the core requirements around quality control, testing processes, worker training. I'm trying to think of some of the other things we built in there. Those are might say that's most of the core of that part of the standard. And then the last part of that is materials recovery, what's allowed. And part of what we've done for all the people that are on the solar panel recycling committee with the R2 TAC is through the consensus, having people like Ricky on our group is to understand what are the constituents, what are the processes involved, how do you delaminate glass, what are there circuit boards in material, where are they located, were there batteries, was there any possibility for any customer data to be on this material? So those are sort of a lot of the questions that we ask the industry specialists to understand how to fit this into the R2 standard, because R2 already manages those from the electronic side of things. So we needed to understand what those were in order to decide how it fit into the standard itself. I want to just talk a little bit about the standard process too. The R2 standard is accredited. It's run by the nonprofit CERI. And when we say it's accredited, that means that a third party not only audits and manages the standard, over time. There's requirements built into how the standard is managed, meaning how often it updates, what are the protocols around public comment, who's allowed to be part of the public comment process, who's allowed to be part of the standard writing process, and then the process of public comment, how that occurs, how many days. It's really strict in how we not only write it, but also present it to the public for feedback prior to publishing. So there's a long process that goes along with revising the standard. And then the audit process is only carried out by third-party auditors who are accredited also. So their organizations are accredited. They're held to particular criteria depending on what it is they audit to. And so primarily the auditing process for the R2 standard has fallen to the certification bodies who typically do ISO certification, which are international standards. The R2 standard requires environmental health and safety and quality control standards concurrently with it. And those are ISO 14001, which is environmental, ISO 45001, which is health and safety, and ISO 9001, which is quality. There's also another standard that's allowed called RIOS, which includes all of the components as well. So concurrently to being certified to the standard, you also have these environmental health and safety and quality accredited standards that are required. So there's a lot of gatekeeping and a lot of third-party checks and balances within the auditing process and protocols around the R2 standard. So the current working group, as we talked about, has industry representative, recyclers, and regulators, and we've been meeting monthly. Our first job, as I said, was to define some of the requirements, and in order for us to know what the requirements would be, we had to really dig deep about what were the constituents that made up the panels themselves and what they look like. And then we looked at the requirements and what those protocols would be for managing the material. That's still part of the process for us. The intent in the group is to have a draft for public comment by the end of this year, and I think we lost the key key person from the Siri group who took another job, so we are looking for someone to replace him. And that might put us off a little bit here, but the intent was to have a draft by the end of this year. The public comment period, I think we do it for 60 days. So we create the draft, it goes out for public comment, people respond. The technical advisory group needs to respond to each of the public comments and then meet together depending on how quickly that timeline is, and either have responses to those comments or decide whether or not they warranted a response. And we may have more than one public comment period. When we revised the standard last time, we actually had, I think it was 3 public comment periods. So you can see that it can extend the process quite a bit. If that's a 60-day public comment period, we could end up with 6 more months until we're actually able to publicly publish the standard. After the standard has been published, there will be that accreditation process that I talked about. So the accreditation, ANAB will go through the standard and make sure that we can demonstrate that all the processes were followed correctly. And then we're really looking at potential release in the second quarter of 2023 if everything goes well. So it's a long process. I think we're going to leave the questions to the end. Hopefully I didn't leave you with a bunch of questions. I just kind of wanted to give you a high-level overview of our process and how that fit into the whole overall recycling situation for PV panels in the US, North America at this time. Lynn, I'll let you take it from here.
All right, everybody, can you see my screen okay?
I can now.
All right, good. Then I think we're probably good to go because one's new to me. So thank you, everybody. Thanks for bearing with me. Al Salvi with the Washington State Department of Ecology. I've been here for
Al, we can't see your slides. Are you trying to show us slides?
Yes. Okay, that's what sorry, that's what I should have said. Let me try to get the slide up.
If you open up your PowerPoint and then go to presentation mode, you'll be able to share it.
It is. Sorry, I'm having trouble here, folks. It says I'm showing screen, but you're not seeing it.
Screen, but what we're looking at is your control panel, with all your different apps and stuff on it.
What up? Let's try this.
Ah.
How are we doing now?
Yeah, you just need to put it in the slideshow, start from the beginning mode. You know what I'm talking about?
Roughly.
No, at the top it says slideshow and then start from the beginning. The orange row. There, from beginning.
Thank you.
And then I think you want to, we're seeing the presenter display. So I think you want to switch it to, yeah, you want to swap it. Yeah, go back to display settings, I think. There you go. Now it's working. Great.
Great. Thank you, everybody. Thank you for bearing with me there. Yes, Al Salvi with the Washington State Department of Ecology. I have a lot of information to get you. I'm going to go through a lot of the history of the program and some things like that. So why don't I just jump in right away and we will get going. And we'll just kind of start out with kind of where things are at right now and the current status of where things are at. The program is not operational. It is due to begin in July of 2025. In some other slides, I'll get to how that came about. You know, in Washington, we don't have any recyclers here in this state. I've listed a few of the places across the US that we know about. If there's more that people know about, I'd really love to hear about that. And really the biggest thing that we've done so far here is the law directed us to develop guidance, a guidance document for manufacturers. I'll talk about that in a little bit. And that did get done, but I will say I don't think we're done there. We need to do some more work there. And as of right now, we have been getting, you know, I wouldn't say a ton of calls, but a fair amount of people like, hey, what can I do with my panels? And we don't have a lot of good answers for them right now. Right now, solid waste landfills are not taking them due to, you know, they believe they're hazardous, so they're not taking them. So a hazardous waste landfill is an option, but at what cost? At that cost, it's higher. There have been a very few electronic recyclers here that are starting to dabble a little bit, taking a few panels here and there, seeing what they might be able to do with them. So there may be some movement there. There may be some things happening there. Also, when we were developing the guidance document for manufacturers, at that time, we were getting a fair amount of inquiries from different people, you know, knowing that this program was coming, and, you know, thinking about getting something set up here in Washington. And so as we get closer to that date, as we get going on this work, we're hoping we'll be reaching out to a few of those folks again, and hopefully we'll see some movement there. This is just a quick visual. When we were, this was back, I think it was completed in July of 2019 when we finished the guidance document. This was the stakeholder group that helped us with that document at that time. And, you know, a lot of these folks or these organizations will be reaching out to again when we get going. Yeah, it was, your name wasn't there, Ricky, but I did see someone from First Solar, so that was interesting. All right, let's get into a little bit of history and what the law says. The original bill passed in 2017. It was primarily a tax incentive bill, you know, to reduce costs for installing PV modules and create economic development. That went really well, and as that was moving along, towards the end, they inserted a section to, hey, look, we're creating all this development. Might be more panels coming to the state being put up. We need to do something on the back end. And so towards the end, they put in a section to set up this recycling EPR type of program to take back the panels. The manufacturers are responsible for the financing, the take back and the recycling systems. The program will only cover PV modules sold after July 1, 2017. After the original law passed, there were a few other amendments that came later. So in 2020, the law changed in a few ways. Probably one of the biggest ones was that the program was now going to include the modules from utility type scale projects. The original language in the bill, it was just worded in a way where those utility scale projects were not going to be part of this program. And when we got that opinion from our Attorney General, we took that back to the sponsor of the legislation, and they intended it to be, they wanted it to be to cover these utility scale projects. So that was one of the big change in 2020. Another change was that the law now was going to allow manufacturers to have a PSO or product stewardship organization that could represent them, their program. The original bill is basically just said each manufacturer must come up with their own plan. And so this is a way for many manufacturers to be represented by one plan that this product stewardship organization would run. It also pushed back implementation from to 2023. And it established a task force to study and quantify PV modules covered by the program. This took place, everything passed, but that provision was vetoed by the governor. It was because of just the economics of it. Anything during that legislative session that had a fiscal cost to the state was pretty much vetoed because we were in COVID times and we just didn't know what the money was going to be used for. So a lot of things got vetoed that year. And then the following year in 2021, it pushed back implementation of the program once more to July 25, which is where we are at today. Okay, real quickly, what's covered in the program? These free standing off-grid power generation systems. These things are all street signage. All these are part of it. The stuff on the home's going to be part of it, and of course the utility scale projects. Things that are not going to be part of it are just basically your very smaller applications, yard lighting, decorations, and other just basic consumer electronics. It's not going to cover that solar powered watch or some of the other things that you might see. All right, ecology's role in all of this. Like I mentioned a little earlier, we created this document for manufacturers, some plan guidance. And this plan guidance is basically, what a manufacturer or the product stewardship organization that might be representing multiple manufacturers. This is just kind of the guidance of what they would need to put together to have a plan that they would submit to ecology for approval. So this was going to help, show them what they needed to have in their plans, so we could get to an approval on it. That document, we learned a lot while going through that document with that stakeholder group that I showed earlier. We're kind of used to some of what I would call your kind of standard product stewardship programs, whether that be paint or mercury lights, electronics. It became pretty quickly became clear pretty quickly when we were working with our stakeholders that the same approach may not work in this instance, and part of that is just the kind of a convenience-based model that so many other programs are based on. The law had certain requirements for those other programs to have so many collection sites per county or per population of cities. And while there was nothing like that put in this law, that's kind of the direction we started to go down when drafting the guidance. And, we came around out of that way of thinking pretty quickly, talking with the stakeholders, because this is a different type of program. And I believe, like Kelly had mentioned too, we were kind of looking at the installers as a possible network to help with the collection and getting getting the panels to a recycler. There is enforcement involved as well. So, when the program's supposed to start in July of 2025, any manufacturer selling into the state must be participating in an approved plan, whether that's their own plan or they're part of a more manufacturers and a PSO running the program for them. We would send a warning letter if we find people aren't participating in a plan. They'd have 30 days to participate, and there is a pretty substantial penalty there for up to $10,000 for each module sold into the state. after that initial warning. So that's something that we'll also be looking at when the program is due to begin. The manufacturer's role, they need to create their own recycling plan or join a stewardship organization. Like I mentioned before, finance the system, so there's no cost to the owner of the module. And as far as right now, they need to follow the interim enforcement policy. It's the conditional exclusion for electronic wastes. And basically in Washington State, we have dangerous waste regulations that go beyond the federal regulations. So there are some state specific regulations that need to be met here. So in order, so instead of like testing every panel or a series of panels to show that they're hazardous or non-hazardous, whatever it might be, if you follow this policy, you're not going to have to test every time, and you're going to be in compliance. It's some basic things about meeting transportation requirements, making sure things get recycled to a certain extent, that sort of thing. They're pretty basic, but the idea is if they're going to go into a solid waste landfill, they need to be tested first. Their plan's going to have to be updated every 5 years, and there will be annual reporting involved as well. All right. So in one of the previous slides, I mentioned how the governor had vetoed a certain provision 1 year due to the cost. Well, Washington State University Extension went ahead a few years later and kind of put together their own study to try to mimic what might have been anticipated in the study that was vetoed. So if people are interested in this, I can provide, provide the document to folks. But some of the key findings that they found, I'm not going to read, everything here. You can see it for yourself, but it kind of went through what the solar market looked like here in Washington. And as one of the biggest things it was, we kind of get a kick out of it. It shows like, as of 2020, the 264 megawatts installed in Washington being 0.26 total of installed in the US. So we kind of get a kick out of that, how we might be the first to run a program like this for such a small market share, so to speak. And another interesting to kind of build off, I believe, what Ricky was talking about, there are some requirements on our law for recycling of the panels, a certain percentage. I believe it was around, 87% or something like that. And as you can see here from the Washington State University study that, they were finding 70% glass, 19% aluminum for a lot of these. And, just by recycling those materials, they would meet the recycling goal in the legislation. So we would obviously like to see things go a little bit more, go higher than that, and we'll be pushing for that. But this is, we'll have to also just go by what the law says, by what the law says. So during this tax incentive phase as well, it was also found that during the time that it lasted through 2018 and 2019, that the market here was dominated by basically just three companies. Here are some other, you can read this again. I won't say it step by step, but the thing I'll focus on here are some of the recommended next steps. We kind of know we need to bring the stakeholders back and work on our guidance, like I've mentioned before. But I think some of these other next steps are going to also be, part of those discussions with our stakeholders to see if we can kind of get to where we need to be going. There's a lot of unanswered questions for us right now, and we need to work on getting them answered. There's a lot of things are just trying to figure out who all the manufacturers are. That's proven very difficult since those tax incentives have gone away. During the tax incentive time, manufacturers had to report their sales, so it was really easy to to figure all of that out. Now it seems a little bit more a little more daunting, let's say. So we're working on a process to do that. And then kind of like the biggest thing that we have to do right now, because of COVID, we got the guidance done, but since then, we haven't made a lot of progress on trying to move this program forward. And mostly that's been because of staffing. We lost our staff person during COVID that was working on this. So right now, I am very close to having the position posted. We're going to be hiring a position to pick all of this back up. We hope to have them hired by the first of the year. And then that person's going to be reaching out to a lot of folks to restart the stakeholder engagement, look at the manufacturer guidance document again, and in general, get to work on the things that we need to do before 2025 to get this going. And that is all I have on where our program is at right now and how we got to where we're at right now. So happy to answer questions. Thank you.
And we have a lot of questions. So let's dive in and get going with the questions. So I think that one of the first questions, I think, for you, Dr. Sinha, is, let's see, where was that question that I'm looking for? So with the use of solar panels being normalized, is there legislation to ensure materials are properly recycled and not made of PFOAs, and I think they mean PFAS, BPA or bisphenol A or other toxic materials? So there's several questions about sort of handling of toxic materials that relate to solar panels, and how we ensure that they're not made with some of these toxic materials, and if so, how they're handled in life.
Yeah, I think this actually relates to the work that the R2 committee is doing. They have, as Al was saying, if you recover the glass in the frame, you're going to recover like 90% or 85 to 90% by weight of the panel, but then the remainder is the solar cell inside. And that's where some of these materials that are being asked about. And so the R2 standard has something called focus materials, where in addition to all the health and safety and environmental management aspects of R2, they say, well, what is the actual material in this product that we want to make sure gets treated by the recycler and doesn't just end up getting discarded or in a waste stream. And so that would be the place where you could say, well, I want to make sure I get these semiconductor metals, or I want to get the polymers, or whatever it is. And that's what this R2 group is working through right now, is defining those focus materials, and then making sure that if you're going to get certified by R2, you're going to have a plan for how to manage these target materials. And aside from that, I can't really comment on the regulation. We adhere to the laws in the countries where we're operating, but we're trying to make sure that the leadership standards do address any concerns on materials.
Al, have you guys looked at all at any of these, toxic constituents that, people are concerned about?
Not a lot up to this point. That's one of the issues in the legislation, is that it's asking for a certain percentage, and they're going to get there with the glass and the frame. So that's gonna be a challenge, I think, for us. I mean, of course, we're gonna encourage we're gonna encourage to go beyond that. There is a little bit of language in the law about paying attention to the rare earth metals, but it doesn't really give certain requirements around it, other than you got to take a look at it. So that's kind of a hard one to enforce. But once we get our person hired to start working on this, that is going to be something they're going to be looking at more, working with our Haz Waste department on some of that to see if there's something other than using our interim enforcement policy, as well as other testing methods or just other requirements that might come from that. Because there may be something that they're going to need to be doing, even if they're not, say, recycling those rare earth metals or recovering them, but they're still going to have to manage them correctly. And so, we'll be working with our Haz Waste department on at a minimum on that aspect of it.
Yeah, I was going to add
Okay.
sorry, this quick thing, the hazardous waste laws are in the absence of any specific treatment standard, that's where you're gonna refer to make sure that you're managing these materials properly. Is you're gonna do the testing, whether it's TCLP, and you're gonna have to manage the material until it's where you can send it legally.
So how are you categorizing photovoltaics? And are they classified as non-hazardous, hazardous, universal waste, scrap electronics? There's a bunch of questions in here related to the sort of regulatory determination. Or, is there a difference between older panels and the more modern panels in this regard? Any comments on that? It's not.
No, I mean, not much than more than I've said is having to working with our Haz Waste department on this. So yeah, at this point I don't have much more to say. I will say this though, I mean, one of the things we're working with our Haz Waste department on is really the universal waste question. We see universal waste being used in a lot of states, whether that might be for paint or other types of products that are being managed under EPR. That would make our life here in Washington State so much easier because of because we go further than federal RCRA. It really complicates these things for us, and we have to write these policies with our Haz Waste program on all of these products to get management guidelines in place for how to manage these materials. If we're pushing them to try to look at that universal waste model that a lot of other states are doing, because that would make the management a lot easier for us here.
Yeah, I wanted to add a little bit. So the characterization of waste is, pretty standard. If you're not in California, you do the TCLP testing and you check your results against the limits for different metals. And if you're in California now, there is a universal waste rule for solar, and that, as Al said, that's getting considered in other regions like North Carolina, Hawaii. There's a few places that are seriously looking at a universal waste classification for solar panels. There's also ASTM has developed a standard for how to prepare your solar panel sample when you're doing a TCLP test. And the reason why this came about is the labs were doing all kinds of different things. Some were crushing panels to a powder, some were cutting them, less aggressively, and they would all get different results. So to try to make things more representative and uniform, ASTM created this standard for how do you cut samples from a solar panel so that they meet the TCLP requirements and are repeatable by different labs. And hopefully that'll result in more repeatable results for the TCLP testing that's happening in the U.S.
Okay, so I think this is a question for you, Ricky. Can you talk a little bit about the energy you needed in the recycling process? You know, how much energy is consumed, or you know, how much energy does it take to recycle the panels, at least based on your experience and your process?
Mm-hmm. Yeah, so one of the things tools that we have used for sustainability for solar is life cycle assessment, which is basically environmental impact method for any process. And so when we developed the recycling solution, we also did LCA on that, and we found that it's like roughly 10% of so the impact of recycling is roughly 10% of the impact of making a brand new solar panel. So it's a pretty, reasonably small impact. And so, to give you, and the reason is like we use about 1/10 of the electricity to recycle as we do to make a brand new solar panel. So there is some electricity required, and it's used to operate those crushing machines and the leaching reactors, but it's fairly nominal. And it definitely, the benefits of recycling in terms of displacing the raw materials, the virgin raw materials, it outweighs the impact. So there's definitely a net benefit. There are new recycling methods out there that are more energy intensive. If they're thermal, they may be less energy intensive if they're purely chemical, and so there's going to be some range as things evolve.
Does First Solar recycle panels from, panels that are not made by your company, but other solar panels from other manufacturers?
We do not at this time, but we have active research in that area. So we have academic research partnership with ASU right now, Arizona State University, funded by the Remade Institute, that is looking at silicon solar cell recycling. And so hopefully, we'll be working together to try to accelerate the silicon panel recycling technology as well. So right now, everything I talked about earlier was for thin film panel recycling, and the silicon, it's a very common product, so it's important that technology also has a high value recycling process.
And then sort of related is, can you talk about the water consumption in the recycling process? Are you using potable water? Are you recycling water? What's that look like?
It's a good question. We have the benefit of having our recycling facility integrated in the manufacturing facility, and so we're able to share some infrastructure. For example, the wastewater that was generated by recycling was going to the same on-site wastewater treatment facility that we had for manufacturing, and we were able to leverage the ISO environmental certifications for environmental management and worker health and safety and quality. Now, we have made some improvements. So whereas we were generating wastewater and treating it on site chemically, we are now a zero discharge recycling facility. So all the wastewater actually gets evaporated, and the distilled water is now reused in recycling. So it's a closed loop on water. And the amount of water, it's not when I mentioned the LCA work, it's not a huge impact. We have published that LCA of recycling, and so I had an email address in the beginning of my talk if anybody would like to see the impact assessment. I'm happy to share that.
Thank you. This could be for either of you. So, we haven't heard in this presentation a lot about reuse or repurposing or refurbishing solar panels. Someone's asking a question, has anyone done a sort of percentage breakdown, perhaps either by volume or weight of solar panels, and how much is reused, repurposed, recycled, what percent's going for disposal, how much is considered hazardous waste? I don't know if that's been done, but that's the question.
Yeah, I don't have a lot of good answers there, other than I know the reuse aspect is another kind of big issue that we need to be looking at. I mean, the law directs recycling; it doesn't talk about reuse, and we're trying to figure if that's going to restrict us in what we can do, because that was one of the main questions that we got from our stakeholders, I think, and also one that we need to answer moving forward, that we'll be engaging them as well, because I even through some of the calls I've been getting as far as what can I do with my panels, there are plenty that they're at certain percentages that are are still viable. There may be a market depending on what those percentages are, and like I said, I don't have a lot of good answers to that right now, but it's definitely one we're going to be working on.
Okay.
Yeah, I can say a little bit there. The R2 group is their hierarchy is reuse first, so it'll definitely be part of the R2 standard for solar. Will include some guidance requirements on what is acceptable for reuse, and the relatively easy part of that is to check the functionality. Is the product producing power at a certain, let's say half or 80% or 70%, whatever it is, of the original nameplate? What is that bar that needs to be set? But then the second part of that is the safety and reliability of that reused product, and that's where there's a gap right now. There's no recertification standard from a national lab or from a certification body or standards body that says, okay, this panel is now safe and will last for this many years and can get a new product label to be put back into the electrical system. That these are energy systems. These are not toys. They need to be robust to the outdoor environment and safe and durable in order to be reused again. So it's not enough to just say, okay, it's still working 80% or 60% of what it should be. And so I think there is definitely some work to be done to make reuse standardized. And but it's at the top of the hierarchy for end of life. So,
question about recyclability of the tempered glass. Does that affect the recycling of the glass, that some of it's tempered, or? And there's also questions about what happens to any of the plastics, and how those are managed, any plastic waste, and is it getting into any of the water and that kind of thing.
Tempered glass, it's a little bit, it's going to have a different breakage pattern when you try to crush it and open up that sandwich that I mentioned. But at the same time, it's usually fairly clean. So like there's no deposition of semiconductor material on that tempered glass. So if you can remove it, if you can delaminate that portion of the panel, you should get pretty high value, high quality glass out of it. So I don't see it as a real barrier. And then the plastics are more of a challenge in that one of the key aspects of making recycling work as a business is to be able to sell your products for a reasonable value and without, also without having to transport them a long way. So having off-takers for your recycling products nearby that are, pretty good use of the material, that's all very important. And that's a challenge with plastics, is finding the off-taker. And so in the absence of that, plastics will often get disposed of. But we're always looking to find, I mentioned the rubber products is an industry that has taken some of our plastic waste and used it for new materials.
So you mentioned just now transportation. So there is a question about the effects of transportation on the recycling rates, on profitability. I assume you guys have looked at that, what, distances these materials have to travel before they become more prohibitive. So I don't know if you can comment on that.
Al, do you want to start, or?
Yeah, not much on that. I mean, as of right now, I mean, when we're looking for a program to come here, we are hoping for a recycler to come here because we just, like any other recycling program, you need to be close to, as close as you can to the recycler to keep those transportation costs down. At the same time, the law directs that it has to be recycled one way or another, and the cost is on the manufacturers. So it's something that, we'd like someone to come here. It would probably make the program more robust and viable. But if not, that material still needs to be recycled. It's still going to need to go somewhere at whatever cost that might be.
Yeah, there's going to be an evolution, because the real challenge today is that the waste volume is quite low. We're talking about thousands of tons, whereas we might be talking about hundreds of thousands of tons in 10, 15 years. When you're talking about small volumes, transport is really expensive, because you're just taking a little bit of a small batch and trying to move it a long way. As the volumes increase, you're going to get more economical transport costs. Now, what you potentially could do is store waste until you have that larger batch, and then you can ship it. There's also the question of like centralized versus distributed recycling, where if you have a large centralized facility like we have in Ohio, we have really a lot of economies of scale there. If you have smaller operations here and there, then they're not going to, the recycling cost is going to be higher. The shipping cost would be lower because you're not shipping it as far. So there's trade-offs, and it's definitely a key. I think I mentioned as far as challenges to recycling, the collection is really a key challenge, and I think it's a place where the private and public sector should work together, because it's not, Al mentioned collection points for other waste types. That doesn't just happen. I mean, there has to be some coordination between the regulator and the industry to make that happen right. And so I think that's a good place for cooperating.
So maybe, Al, you can help with this. Do you know which states ban the landfilling of photovoltaics and therefore mandate recycling? Or have you guys looked at that, other states besides Washington, ultimately?
We have not. My general answer to that question, would be for the, depending on the landfill, solid waste landfills, at least here in Washington, they're not supposed to take dangerous waste. And so they have policies, they have procedures in place for something to come to them that have to meet certain criteria for it, to enter their facility. And here, here in Washington, we may go a little further on the dangerous waste side, but I would think that that's the same requirement in other states. So yeah, I would say that my guess would be that it's pretty similar. It's like, unless it gets, a landfill's not paying attention, or, something gets, brought in in the truck that's, covered and nobody can see it. I know the landfills here are going to be turning those things away.
Okay. So are there any constituents you haven't yet identified in solar panel glass that will make it hard to recycle it, such as like we had with lead and CRT glass? I mean, older solar panels, some of them had lead. I don't know if the newer ones that you guys are making have lead, for example.
So the standard that I mentioned in Europe that was created after we was passed, it was developed by an organization called Centralized, and they're a European standards body, and they have these PV specific treatment standards, and they have 3 metals that they regulate: cadmium, lead, and selenium. And so if you're a recycler, according to these standards, you have to make sure you process your waste until the glass that you're producing falls below the thresholds, the limits for these 3 metals. And so those are the, and the R2, I mean, the R2 is not final yet, it's in draft form, but they are leveraging the work done in Europe. So those 3 metals will likely be, well, may be part of the R2 standard as well, as far as the focus materials that have to be managed by the recycler.
Okay. Can you talk a little about inverters? We've got a couple of questions about inverters and what, recycling them. Does the law, in Washington State cover those units? And how are those part of the recycling collection and recycling process?
To my knowledge, the inverters have not been part of the discussions for the recycling, and we're just focusing on the module. So I don't have a lot on that at all on the inverters. That hasn't really come up here.
Ricky, did you want to comment on that at all?
The only thing I can say, there was one of my slides talked about leadership standards, which are fairly recent, and there's one that I should expand on, which is called EPEAT. EPEAT is a electronics, it's a registry for sustainable electronics, and it's used by the federal government, by state agencies to buy products that are sustainable, that are the leaders in their industry. And a year or 2 ago, a solar and inverter category was added to EPEAT. And so if an inverter has this EPEAT label, in order to get that label, it has to have a recycling program as part of its offering to its customers. And so I haven't checked the EPEAT registry for the inverter products lately, but that would be an example of a movement in the industry to accelerate recycling of inverters. And otherwise, I don't have a lot of firsthand knowledge on that question.
Okay, thank you. So a couple of questions for you, Al. What impact do you think the law in Washington will have on solar panel PV growth in Washington State? And apparently, one of the questioners asking from an anonymous state that there's sort of a rumor that that some of the PV manufacturers won't be selling into the state because of the law or the mandates. I don't know if you can comment on that. There's a couple of questions regarding that.
Yeah, I mean, we heard that a lot during the stakeholder work. We'd ask questions about certain things, and then, the comment would be, well, we're just not going to sell into Washington State. So we did hear that a lot. So it wouldn't surprise me if that if that does take place, I mean, I can see why people might make that decision. We are such a small market, you know, at this time. So yeah, we've heard that, but at the same time, you know, whenever there are new programs, new requirements in areas, you know, as a regulatory agency, we hear that all the time. That, okay, yeah, well, we're just not going to do this anymore, or we're not going to, you know, there's always that. I think in this instance, I would call it, it's probably, there's probably a little bit more to it than just, you know, a scary talking point or something like that. So I don't know what will happen with it, but that wouldn't surprise me because we have heard that from some manufacturers.
Okay. I don't know, Rick, if you hear any of that kind of talk, or, you know.
I would say that that's probably the elephant in the room. You know, it's a tough question to ask, Al, but it is the challenge of being first. You know, you're putting yourself out there with a program that is not mainstream. You know, if you were in Europe, everybody's doing it, right? There's European Union wide, you have to recycle, and there's this whole ecosystem of product, they call them PROs, or product responsibility organizations. You use a similar term, Al, I forget what you use, but they're basically the middleman that takes your money as a manufacturer and then connects it to the recycler and makes sure that you're meeting the law. And that whole ecosystem exists in Europe. It doesn't exist in the US today, but it will have to. I think it's going to be the most likely route to compliance in Washington, is because not every manufacturer is going to do what we did, which is create our own specific program, and they're usually going to rely on some third party to do the work, assuming it's affordable. And well, if you have to do it to be in that market, then you have to do it. And so anyway, so I think there's definitely it's a great question. I think you answered it well, Al. So.
All right, we have a lot more questions, but I'll try to end with one that's kind of interesting. Do you know if the recent Inflation Reduction Act or the bipartisan infrastructure law addresses recovery of critical minerals from end-of-life solar panels, or include related items such as sourcing of critical minerals or domestic panel components and panel manufacturing? And, you know, how does that law in any way incentivize sort of this kind of the recycling we're talking about for some of these materials, and you know, using that as the source of the raw materials rather than importing them or extraction?
That's a very good question. I think the answer is yes. So there's the Inflation Reduction Act includes both an investment tax credit for recycling, PV recycling facilities, and it includes a production tax credit for critical minerals that are domestically produced. So it's going to do a lot to, if there's like a close call where, you know, something may or may not meet the ROI, if you add in this extra production or investment tax credit, it may put it over the top and lead to more sustainable domestic production. All that being said, you still have to have a business that will withstand, that'll work regardless of subsidy. Otherwise, you know, you're going to falter after a few years.
I don't think I could have answered that. No, that I couldn't. I couldn't do any better than that. That's for sure.
Okay. Well, we have a lot more questions we're not going to get to in the 1 minute that we have. Lynn, I don't know if you want to begin to wrap this up. Lynn, are you still with us?
Then you're muted.
Okay, well, so to wrap things up, I want to thank you guys for excellent presentations. I want to reiterate that NERC and NMOA, but NERC first for sure, will be posting the recording of today's webinar on our respective websites, nerc.org, nmoa.org. NERC will probably be very prompt about that. I will probably be a lot slower. The slides will also be available on both websites. Again, thanks to for great presentations today. A lot of interest on the part of our participants. We really appreciate all your great questions, and have a great rest of the day, everyone. Thank you so much. Bye-bye.
Thanks.